Hello everyone, it's Richard here. In this video we're going to be looking at the Bq Hephestos V2. This is the finished machine, and also I'll be showing you a little bit about the process I went through to build the machine up, some of my thoughts while I was doing that. May help you if you're deciding to buy a kit, the Bq Hephestos V2 or any other 3D printing kit. Some of the things that you find and you discover as you build up a machine are very similar in a lot of these kits. So I will put that at the end of this video, but first I just wanted to show you how where I've got to with the Bq Hephestos V2 and some of the modifications I've made to it so it works well for me as a 3D printer. So in the previous video I was explaining how well the Bq machine works for flexible filaments. Basically FilaFlex, NinjaFlex, SemiFlex, any of those types of flexible filaments work incredibly well with this machine because of a great extruder design, and also the fact that it doesn't have a heated bed, so it is limited a little bit on some of the materials you can use. So really for me this is the best machine I've found that prints flexible materials, thermoplastic elastomers. And with that in mind, I've made some modifications to the mechanics of the design to make it a little bit easier for me to be able to print thermoplastic elastomers, because I like switching colours and I like changing materials and colours and types as I print, and virtually with every print that I do. So originally the Hephestos V2 does actually come with a spool holder. They deliver this, which sits on top there, and you put the spool on and it sort of sits around, but it's a little bit clunky and it wobbles around a bit and doesn't really know what it's supposed to be doing. So I didn't particularly like that, so I haven't really used that at all. But what I have done is put a little bit of extra framework around the machine, and some of that, there's twofold reasons for that. One was mainly to give a tiny bit more structural support to the machine, because I was noticing a little bit of flexing in the aluminium frame, and also to hold a number of spools. I wanted to hold quite a few spools, and there's sort of 7 spools you can put on there, which is quite a bit of weight, so I wanted a decent structural frame. So I've used some 20mm aluminium box a channel on the back here, and just bolted those two together and affixed it to the back of the machine, and one bolt fixed here. So it's not overly constrained, it's just it can flex a little bit, and it doesn't actually cause any problems with the weight of the spools on the rest of the machine. And it also makes this a little bit more rigid, so the machine is now even stronger than it was before. One good side effect to that is that actually I've put a bar at the back and been able to mount the power supply brick and all of the cables and tie wrap those away, so they're not actually going to get knocked or damaged. One of the things you'll note in my build videos and the previous video I did was that I was very concerned about the connectors poking out the back. They're very light connectors, and some of the cables that plug into the back of there could easily get knocked or damaged and possibly cause the electronics the connectors to be damaged. So that's great, because that's all nicely protected now with the framework around there. It's all tied in. I can just basically plug the power straight in. So that's really the main changes. I've got a piece of build tack on the bed surface now, and that's mainly because I found it a little bit easier to be able to print if I do want to print with PLA on this machine. Build tack is not great actually for thermoplastic elastomers as it stands. If you try to print straight onto build tack with TPU, any type of elastomeric material, it will bond directly onto it and virtually impossible to remove. So you've got to be a little bit careful with that. And what I've done is I've coated this in a wash of hairspray basically, so you've just got quite a thick layer on top of that, and that works really well then for both PLA and thermoplastic elastomers. So really that's the main changes. I'm going to make one more change, and that's to add a little brush at the back so that the nozzle can brush itself clean just before a print. And with that I'm going to take a tip from some other 3D printers that I've seen that have been using a section of toothbrush. Basically you just cut that piece off, mount it at the back, and then at the start of your G-code you can have a routine that goes over and brushes on the toothbrush and actually cleans the nozzle. So it's not abrasive, it's not like a wire brush or anything like that. and it just gives you a nice clean nozzle to start your print with. So I'm going to mount that at the back and just do a little bit of changes on the start routine, and then that'll be it really. I've been printing with it for quite some time now and doing quite a lot of prints and really tuning it down and really refining printing for FilaFlex, and I've been absolutely astounded over and over again how much more quality I can get from FilaFlex and TPU plastics in general. Thermoplastic elastomers are quite difficult to print with, but actually I've been printing this at 0.1mm resolutions and it looks better than PLA. It's absolutely stunning. So I've printed a whole load of, you end up printing lots of little test pieces over and over again to get better at printing these types of elastomeric materials, and a lot of stretchy bands, and this is a very, very fine stretch band. It's only a single layer. As soon as you get your cooling right, you can actually do all sorts of things with these types of materials. One thing I've also been doing is doing a lot of mould making, which has been really interesting, especially as it's running up to Christmas now, so chocolate moulds and other types of things, and getting some really high resolution quality in some of these moulds, 0.1 resolution layers, and the actual quality and the surface finish on these is just astounding. It's really amazing. So I've been really thrilled with how well this is working for TPU. And some of the other moulds, I've got a little one here that I haven't actually opened up, maybe we'll do that in a sec. And this has got soap in it, so this is a soap mould. Actually done, my wife was doing some soap moulding in some normal silicone moulds, and I thought, why not have a go at printing one with FilaFlex. So this uses an OpenSCAD script to generate a mould, and let's see what it's like actually. I'll do some close-up shots, but this will be really interesting. So it's got a little hole at the top where you can pour the liquid soap into, and it should cure. So we'll just see if this is going to come off. One thing I've noticed with most moulds that I've made for most materials with FilaFlex is that nothing sticks to FilaFlex, so it's actually really nice. If you try and do a chocolate mould with PLA, you can't really get the chocolate out very easily. You can do it with ABS, but then it's not quite as nice material. I've got less worries. Oh, there we go. So that's come off really quite nicely, and it looks like, I'll just pull that piece out the top there. That's my pouring mould. So it looks like that's going to come off really nicely. Ooh, a little bit stuck in the top because of the mould, the pouring entrance. Ah, there we go. So yeah, little soap mould. That's quite neat. So moulds and all sorts of other things, anything you require a flexible filament for, this printer's been really good for that. So now I'll show you a few of the video clips that I did while I was actually building the machine up. Maybe it'll be helpful to you if you're thinking about buying this as a kit and building one yourself, or building another 3D printer from a kit. So thanks ever so much. Hope you enjoy the rest of the video. I'll see you again soon. So here I've just about finished the first stages of construction of the 3D printing kit, and I must say it's gone together very nicely, very easily. The instructions are easy to follow, and the kit itself has a lot of pre-made parts. So there's a lot of parts that already have all the studs fitted, obviously made out of metal. There's no 3D printed parts in this kit at all. They're all either machined out of aluminium, bent and formed powder coated aluminium, and everywhere where there's needed a stud or a bolt or a threaded hole, then that's already done for you. There was a tiny little bit of scraping away of some of the powder coating on some of the holes I had to do, but other than that it was actually a very simple procedure to follow to actually assemble all these modules into the 3D printer. So I'm really only still at early stages. I just wanted to capture this setup at the moment to give you a little bit more of an idea of what this printer is all about and how it's going to go together, and the sort of level of technical competence and ability you need to have to be able to do this, which is, Actually not a lot. I think most people could actually put this together without a great deal of knowledge of 3D printing. The instructions are very simple, sort of IKEA-like instructions, step by step, and everything fits nicely. So you get all the tools you need, all of the Allen keys, all the nuts and bolts and everything else you'll possibly need to actually put this machine together, so you don't really need a great deal of other things. They've gone to a lot of trouble as well to make it nice, to make it a nice finished kit, and I can see that by already some of the plastic pieces that you're asked to fit at this stage that will cover that will guide the cables down into the electronics at the bottom, which is really nice. The other thing that's good is a lot of parts are supplied with a rubber membrane that you have to pull off and push usually onto the metal parts, and then put things like the motors and other parts of the machine mounted to them. So actually they're noise isolation pads. They cut down on vibration and noise, and basically just make them feel a lot nicer when you're fitting these together. Most parts are fitted onto other small sections, so you create these as modules and then you screw them to the overall frame, and everything else really screws to that. All the electronics are fitted onto that system as well. The electronics come pre-made, obviously, and also so do all the cables with all the connectors on. I haven't looked in detail at what connectors have been used yet. I'll do that as I progress through the build, but they look reasonable at the moment and look like they'll go together quite straightforward, quite easily. So that's really where we've got at the moment with the construction. It's gone together very nicely, and I'm moving on to assembling more of the mechanical parts and then eventually the electronic parts, and then the fun part of actually getting it up and running and working. So we've got linear rails and beautiful movement systems here. These are H-wing rails and beautiful carriages, proper ball, captive balls, ball bearings in there to do the movement. We've also got very nice Z-axis motion here with a proper nut on top, and all of these are machined aluminium pieces as well, which is really rather nice to actually see that someone's gone to a lot of trouble to think about these parts. If anything, it might be even just slightly over-engineered. A lot of people would have used 3D printer parts to create this type of printer. This is all machined and formed and bent metals to do the same thing. So we've got the carriage at the front, and that's sort of what it's going to look like with the display up here with the electronics, and the carriage which is moving, and obviously up and down and forwards and backwards. So that's where I've got to at the moment. I'll come back to that in a minute to show you how far I get. I've been taking notes of the instruction details as well as I go, so it's taken me slightly longer. I think in total, we'll see how long it takes, but I've taken an hour or so just to get to this point, but I've been taking notes. I imagine it's going to take a few more hours to get it all up and done, finished, and ready to be calibrated, so we'll see how it goes. So we've been moving on quite quickly now and assembled a lot more of the kit, the printer, and now we've put in everything at the back here, which all the electronics and parts sit into, so you can connect at the back here the power. So this frame was really quite nice. I found this very easy to set up, very easy to put together. The actual hardened M8 ground rods here have nicely tapped ends, really nice countersunk and tapped, and that means you can screw M4 bolts straight into the ends of the smooth hardened ground rods, and that's really nice. So the whole thing, there's even some ground rods up here to bring the whole thing together. It makes for a very solid back assembly that's basically hidden away because this is the back of the printer. So all that goes around there, and then we've got quite long rods coming all the way to the front. So this is actually quite a large print area, this machine, and we've got nice little pillow blocks with really good LM8UU linear bearings on here, and they attach to this. They attach to this assembly, which I've just put this piece on and just put the belt on. So I'm about to fix that in place. So I'll just show you another quick portion of the build, showing you where it's got to. So I'm wondering where I'm going to put my filament for printing. I'm not sure whether that's been thought about in the design yet. Maybe I'll find out towards the end. It's got to be obviously somewhere at the back here. I'm wondering whether or not they could have used these, but maybe there's a plan there somewhere, so we'll see. Other than that, it's got a really nice little foot at the front which you can adjust to make everything nice and level and stable. So far, feeling a very, very solid machine indeed. So we've now just finished all the mechanical assembly. The last piece to put in was the Y-axis bed stage in the bottom here, and that went on very, very easily. It all just mounts onto the pillow blocks for the LM8UU bearings and moves nicely backwards and forwards. We've got a 3-point levelling system which has got these little turn wheels here, 2 at the front and 1 at the back here, which is great. It's nice to see a 3-point levelling system being used instead of a 4-point, which is really just not a great idea. So 3 is all you need, and it creates obviously a perfect way to level your platform. So that's all done now. The only other thing that goes on top is the build platform, and what BQ have done here is they've got a glass sheet that they've bonded to a piece of steel, powder coated steel. That's because they use an inductive bed levelling system, and this little one here, it's a little inductive sensor that they've developed themselves actually, that is quite nice. They tell me that this has got a repeatability of around 40 microns or so. So apparently a lot better than many other systems that are out there and many other commercial parts you can buy ready-made to do inductive sensing. So I'm going to definitely be testing that and see how well that really does work. But the idea is that obviously it senses through the glass and measures the distance of the inductive of the metal surface on the back using inductive sensing method. So this just pushes on, slides on, and we've got 2 little clips, 2 little fasteners at the side which just lock down and lock the bed in place. And you'll notice there's no heated bed, so that's something I'll come on to in a little bit, but there isn't a heated bed on this. It is quite a large build area as well, so we'll discuss that in a little bit more detail in a few minutes. And that's really the main mechanical part of the design. This is pretty much how it's going to look when it's finished. It's obviously got the extruder which we need to fit on. This comes ready, assembled and prepared, so you really only just need to connect up the electronics and feed in the tube, just a feeder tube into here where you can push the plastic filament into to start printing with. So that's pretty much ready to go. Everything's set up. Might need to tighten a few things, but we're pretty much ready to set up on there. And then we'll start fitting the electronics. The electronics obviously fit at the top. BQ have done their own display. This is a graphical display. And they've also done a respin of basically it's a ramps setup board all in one, and they've got the Texas Instruments 8825 DRV8825 driver chips on there, and quite a lot of fairly small connectors, which I'll see how we go with those. I'm not a huge fan of these non-polarized single pin headers. They're only really rated at about 1 amp per pin, depending on the crimp pins and the way that you do it, but we'll see. I think this should be generally a fairly low power system because it doesn't use a heated bed, and everything else is fairly low powered. It's still all running at 12 volts, so unlike a lot of printers now moving to 24 volts, some are using 16, 19 volts, but we've seen a lot more printers moving to 24 volts. This is still running on 12 with a 12 volt brick power supply that comes with the unit as well. So we'll certainly get all of this set up now and start with the wiring. As I said before, the wiring all comes nicely prepared for you, and it's even got some ferrite cores on here. So someone's done some tests to see whether or not this is ever likely to pass EMC regulations. Whether or not it does, who's to know? I haven't found any documentation yet to prove one way or the other, but at least someone's gone to the trouble of actually thinking about the fact that this might need some ferrite cores for EMC purposes. So we're going to do that now, get that all fitted up, try and get that done before I run out of light to take any more video. Okay, so we're all built up. The new BQ machine is assembled. I've just put all the electronics in and the wiring. They went in very well. It has a very nice cable chain system which anchors at 2 points here and 1 point here to allow a nice moving carriage with all the cables nice and neatly organised. A little bit tricky getting all the cables into the right lengths. Made the mistake of anchoring the cable chains down before actually realising how long the cables needed to be to connect to the extruder, so I had to end up disconnecting that and refeeding through the cables and doing it again. So I'd recommend just giving yourself enough cable length there, or even measuring it before you screw these down. Other than that, everything has gone together rather well. I've got the little sensor board on the bottom here. This is an inductive sensor which senses the surface of the build plate distance, so it does some auto calibration leveling. And we've just got normal sensors on the X and Y axis, which is fine, so they're just locating the home position. And then everything else has been neatly organised around the back. So here we've got the cable chain coming down, and again the cables are just long enough. I would have preferred them to be ever so slightly longer, but they all do fit, they all do manage to reach into the electronics, and they all fit nicely inside. So that's all tucked away. There are some cover pieces that I'm going to look at putting on now that just cover up the cables and make it look a little bit neater and tidier. But as you can see, it's all quite well thought out with where the cables are going to run, and the cable chain pre-made with all the crimps and connectors on. Actually, they all fitted on really well. They felt very solid and very secure. So BQ must be using some really nice crimps to go with these connectors, which is really good to see. I've seen a lot of really bad crimps that feel very loose and very wobbly. These fit on, they fit really well. So I've got no doubt that's going to be okay for this type of system running in this way. What was also really neat on the electronics was that BQ have produced their own little electronics control board, but all of the heat sinking is pushed through the back of the board, and it's not just dissipated on the board. There is actually a thermal pad and then a block of aluminium that then also connects to the base of the frame of this printer. So all of the heat gets dissipated eventually through the frame, but it does actually go into a thermal mass that can then actually cool down. It means that there's no fans at the back, so I'm hoping this is going to be quite a quiet machine to run. And it's only really got the cooling fans on the motor assembly for the extruder, and obviously the fan for cooling the part that you're printing. There's no other fans, and the power pack that comes with it is just a brick power supply, so there's no fan in that either. So it should be quite a quiet machine, which I'm going to find out now. So I'll just do one more check, and then I'll be powering it up and getting the software ready to see if we can get it printing.